So let's start off very quickly. If you're joining this stream and you don't know the context, I made a 4-minute video earlier this week describing what I want to do. I want to build a project in C++ that does all sorts of video processing to create an app that can be used for live performances, to create visuals for live performances. And I thought it would be very interesting to live stream the entire development process, to kind of make this whole field a bit more accessible, because from my experience of just exploring these libraries and trying to learn how to do this, how to code this project, I found it quite tough to get good resources on how to do things. I was stuck for like 2 days just trying to get the library to link properly and to compile. So I want to go through, and as I solve these weird problems, show them to you. And hopefully, if people join the stream, they can aid me as well. So if I'm struggling with something, maybe you can spot it and help me out too. Okay, so overview of this stream. I'm going to first explain in detail the app I want to develop. If you're not interested in that and just want to learn how to set up FFmpeg and how to start decoding video files in C++, skip through to a specific point in this video where I start doing that. I'll put that in the description. If you're watching live, obviously you will have to listen through the first explanation. But yeah, first, I'm going to explain in detail the app I'm going to make. Second, I'm going to set up a basic app that allows us to display things on the screen. I'm going to be using OpenGL for this, and that's going to help in what we're going to do later, which is decoding video files in FFmpeg. But if we have a basic app that can display stuff on the screen, then we can start displaying the stuff we're decoding on the screen. So I want to do both of those in this one session. Right, so what is this app that I want to make? If you've seen the video, you've already heard about it, but I will give some more context this time around. Essentially, it is a visualization tool that should embellish a live looped performance for music. And I'll give you the example that I used in the initial announcement video, and we can look through that for a second. So this is me in my bedroom at like 1 in the morning recording a live looped performance. And how that all worked is I set up, let me show you the Ableton project if I can find that real quick. Stream announcement? No, stream demo, streaming. Demo song live project. Okay, so what I wanted to do is create a couple different layers of harmonies that I would layer up and then could play in the chorus. And the way I did that in Ableton is I've got everything in the arrangement view. When I start playing from here, let me set up the right, that should be correct. So we've got this sample that I'm using from Yusuf Day's Alpha Mist, Love is the Message. And it starts with all of this. Not sure if you can hear that. Yeah. So we start with this loop here. And here I start recording, like the automation allows me to start recording a looped region of a bass. And then we play this guitar loop and I start recording with automation a vocal, followed by another vocal, followed by another vocal. So the time at which I record all of my loops is set ahead of time. So it will look like this in the end. So that's my bass loop, and that's looping now. I'm laying on another harmony. So we've got two of them at the same time now. If I skip through the video, we'll get multiple layers. We have like 3 layers. Now we have the verse. The audio quality here is shit for some reason. Now you're far ahead, curling up your toes. And now we get to the chorus, and we have those backing vocals again. When I take the picture, take the mixture. So, I don't want to go into too much detail here, but during this performance, I was recording loops, and later on in the performance, I'm playing those loops. And I can explain that to you now because I'm sitting here like separate from the performance. But to anyone in the audience that's not completely paying attention, when they hear this chorus, it might sound to them like I'm just singing one thing and playing one thing, and everything else is just a backing track that's been prepared. And they might not be quite as engaged in the performance because it appears to be just a performer doing one thing. It's not a very impressive feat. However, looping all of this stuff and recording everything in the moment live, that is actually quite impressive, and I think that is quite an interesting thing. I want to draw attention to the fact that this is all looped live, and I want to show that on a screen. I want to project something so that people can see, so that they can see what they're listening to. And the way I suggested doing that in my stream announcement, if I go ahead here, was like this. Hello, my let me find it. Yeah, this is how I wanted to loop vocals. Perhaps they would look a bit like this. When I take the picture. So during the chorus, you would see a video for every sample that's being played. The only thing missing here is the guitar sample because I don't have a video for it. But you would have videos of pre-recorded samples, and you would also have captured moments from the live performance being projected on the screen. So I want to have a live looping app that follows exactly what's happening in an Ableton Live set or in whatever program you're using to make the music. And whatever you do with the music app, it should replicate it visually behind you on a projection. So how does that work for the performer? The performer would, when they're creating their live set, provide video material for all of the pre-recorded samples that they want to project on the screen. And then they also set up a webcam or some kind of capture device live that's looking at them, so that whenever they're recording loops live, the webcam will record the video for that loop, and whenever they play that loop back, the webcam video will be projected behind them. If that makes sense. You can imagine with this video here that all of the videos that you see of me would actually be recorded live on a webcam, so that we're creating this tapestry of, or we're creating this grid of visualizations or of clips that are all actually based on the live event, and that are proving to the audience that this stuff is not created, this stuff is not completely prepared beforehand. Like, there is a real performance happening in front of them that's creating the sound that they're hearing. Okay, so I would like to give more detail to how this would work from the perspective of the performer, but right now I think that's about enough. The main point is that the performer shouldn't be doing anything extra to make these visuals work. If they're working through Ableton or they're using a looper like a Boss looper or a loop pedal system, I want to find a way to get the data out of their hardware or their software to be able to automatically create the video counterpart to their audio performance. I don't want them to have to do any extra work during the performance. They should focus on the performance. But okay, what I will detail now is how can this work from a developer's perspective? What's difficult about this project, and why do I kind of want to do it? So the way it works internally, how the system will work internally, is it's reading state from Ableton or reading state from whatever device you're looping on. I think I'm going to start with support for Ableton and then work my way outwards. It reads state from Ableton, And it can do this in a few different ways. One way it could do it is through intercepting MIDI messages. Let me show you this. So Ableton Push. So you've got devices like this. You've got the Ableton Push. You've got also the Akai APC 4T. You've got cheaper versions like the 72 version, the APC Mini. And these, oh no. Let me just go images of the Ableton Push here. So actually I prefer the way the Akai APC looks. Yeah, so let me show you this. Can I just get the image? Yes. Okay. So what you have on this Akai is basically a physical equivalent of the clip view or the session view that you have in Ableton. You have one button for every clip that you want to play or any clip that you want to record into. Then you have like the record enable buttons, and you have the scene launch buttons here. So you can basically control all of Ableton through this MIDI controller, which means that whenever you do anything in Ableton or whenever you do anything on this device, MIDI messages will be sent from that device to Ableton. And the way MIDI works on Mac at the very least is that those messages are global to the entire computer. Any program that's listening to MIDI will receive those messages. So you can run a program in the background that receives the same messages that Ableton does, and from those messages can figure out what you're doing in Ableton. Another thing that happens is Ableton is sending messages back to this APC to color the buttons, to show which slots or which clips are full with data and which ones aren't. And the information that it's giving back, we can use that. That's kind of an even better way to figure out what the state of Ableton is, because Ableton will be directly informing us about which clips are being played, when they're being played, and also the timing information. So there's lots of information running around on your computer that actually gives away what Ableton is doing. All we have to do is collect the right data and in an intelligent way reproduce the internal state of Ableton from that data. And once we have the state of Ableton and we know which clip should have which video, we can then figure out which video to put on the screen. So we read state from Ableton, and then when we decode the state, we figure out what's being played. What is a pre-recorded sample being played? Is a clip that's being recorded during the session being played? And based on that, we can determine whether we need to play back a video that's saved on disk, or whether we need to record from the webcam, or whether we need to play back a video that was recorded from the webcam. So you have the Ableton state, you figure out what that is, and then from that state, you figure out what you have to do, or you being the program, what the visualization tool has to do. And from that information, you can basically break it down into simple play, stop, record instructions. So you would have an instruction that you can tell the video player, like, play this video at this time for this length of time. And then you would have a stop instruction where it's like, stop playing this, even that you were looping it for a few minutes, now stop playing the video. Or record instruction, which is like, from this point in time, start recording the webcam because I want to use that material later. And then you'd have like an additional play instruction specifically for playing webcam recorded videos. So we've broken down, like we start with the Ableton data, we break it down into what clips are being played, what clips are being recorded. Then we break that further down into what does the video engine have to do? Which videos does it have to play? What time does it have to play them at? And if there's any recordings it needs to make, which ones are they? When do they have to happen? Right, so that is basically the external interface. Everything from then onwards will actually just be a generic video player with a few custom features of recording. So that's where we get to the main system, really. So the main system will receive these play, stop, record instructions, and based on that we'll handle all the necessary video processing to get that material on the screen. So in the case of a play instruction, it will find the associated video file on disk, it will open it up, it will start decoding it, and And then as it decodes out frames, those frames will be placed on the screen at the right time, synchronized to whatever the instruction told it to be synchronized to. In the case of recording, it will have to open up some live video feed that can come from, again, a webcam or a video capture card, and it will start getting that data in, and it will have to encode it. It will have to encode it into a compressed format and either store that on disk or store that in RAM temporarily. And as it's encoded, as it's building up this file, at some point it will get a new instruction to play back. And so as it's building up that file, it will go into it and start decoding and playing it onto the screen. So that's going to be the most complicated system, because you've got files that don't have a fixed length. Like you might be recording something spontaneously and then having to play a bit back of it spontaneously. So that's going to be very complicated, but I'm going to see how that goes. That'll be very interesting to figure out, because we're essentially building a streaming video application where there isn't any start time or end time. It's all just video material and timestamps and like looped regions. And yeah, it's going to be a bit of chaos to structure that properly. But that's essentially it. That's what I want to do. I want to replicate whatever audio is happening in video. And I think the kind of video processing necessary to do this will be very informative for anyone who wants to do any kind of real-time video processing application. Right, okay. Next thing I want to explain, like, how do I want to implement this? So the implementation for this will be, there are a few ways you can implement this. So there are a few things that already exist, which I want to show you. Yeah, let's go over here. So VDMX is a very popular tool in professional. It's a professional video DJ software, and it's got a pretty big price to it, but you know, not unusual for audio video performance software. And it's got a massive system that allows you to do all sorts of crazy things. And I imagine that I would be able to do my project in VDMX, which will have the benefit that it could plug right into any other visuals that you're doing. However, I don't want to do this necessarily because VDMX seems like a big system, and what I actually want to do is explore the more low-level concepts of video processing. And I want to see, like, okay, how can I do this from scratch or from like the bare essentials as opposed to using a big framework? Yeah, and so what I want to do, instead of using something like VDMX, I want to use I want to do it in C++. And so for C++, if you're doing any video processing project, there are multiple options for how you can build it in C++. So let me show you. There's one big one, which is Juice. So the Juice framework is a framework developed by the guys at Roly, who make these software and hardware instruments. And Juice is a graphical user interface audio processing framework, and it's cross-platform. It allows all sorts of crazy stuff to be done. So if you want to make a graphical user interface application that works on Mac, on iOS, on Windows, on Linux, Juice could be a very good place to start from, because they basically do everything for you. And I believe their framework and their library is very nice. I haven't used it myself. I was speaking with someone about my video project, and they have created a video engine for Juice. So if you're doing any work in Juice, you can also use a video engine there that called, let me find it. I have it written down somewhere. Okay, Foley's Finest video engine. So this Foley's Finest audio software company have created a video engine inside Juice that adds a few classes that allows you to process video files directly in Juice using the same API, and also render it and display it on the screen. And what he's trying to do is essentially make an entire video editor in the Juice framework that's open source. So I believe everything that I want to do would technically be possible in Juice, but again, I want to explore the more low-level, fundamental ways of doing video processing. And I think the layers of abstraction added by Juice are don't interest me so much. Okay, so another big one, if you don't want to use Juice, but you do want to get off the ground working very quickly, is OpenCV. So OpenCV is I think a Google project, but it's basically open source framework for computer vision processing. So any kind of stuff like face detection, mapping, like probably a lot of the Instagram filters and Snapchat filters you see will be using something like OpenCV or similar. And OpenCV has everything you need to do stuff with video processing. And I think this would be a very interesting way to explore it, because OpenCV seems really cool. But again, I wanted to go a bit more low level for this project. So I've finally, to get to the core of what I'm doing, I'm going to be using FFmpeg, which is a open source encoder and decoder for video files to be able to access the video data that I want, and then OpenGL to render my video data on the screen. So super simple, just C++, OpenGL, FFmpeg, and there's this one thing that I need called GLFW, which allows you to create just an OpenGL surface cross-platform so that you can render stuff through OpenGL regardless of what operating system you're on. That's what I'm going to be doing. Again, not the best summary I could have given, but that's essentially it. Okay. Hope you're still with me. Let's look at the timeline. So first thing I want to do is getting pixel data on the screen. Then I want to start decoding some video frames, and then I want to render video frames on the screen. That's what we're going to be doing today. These streams will start out a bit like tutorials, and as I progress through this project, it will turn into me learning and me not necessarily teaching and just trying to figure out how to solve a problem. And that will be quite interesting as well. But first of all, to get up and running, I will be basically leading you through how to set up FFmpeg, how to set up OpenGL and GLFW, and how to start rendering stuff on the screen. So let's do that.